In the last video, we talked about how payment channels on the Lightning Network work similar to an abacus, with balances sliding from one side to another. Nodes are borrowing from each other to pay one another constantly, with each transaction shifting the funds of up to 20 channels. A few thousand transactions can change the state of 100,000 channels in the network. Along with constantly shifting channel funds, you have nodes going online and offline, and channels being opened and closed. What you have is a network in a constant state of extreme change, which is why onion routing is an odd choice. Onion routing is not a path discovery solution like we need. It is a way to keep nodes blind while they relay information after the path has been discovered. Onion routing is commonly associated with the Tor browser, which uses onion routing as an anonymization technique. It's called onion routing because, like onions, it's made up of layers, each layer containing the instructions on where to send the packet to next. In a 5-hop example, let's say we have already found a path from node A to node E. Node A maps out the path and begins to work backwards, encrypting forwarding instructions for each individual node into a separate layer, like tearing up a map into equal pieces and distributing them, so no one individual knows the whole path. When node B receives the packet from node A, it is only able to view its specific layer, which tells B to pass the packet to node C. Node B doesn't know if node A was the original sender or if node C was the end receiver. Therefore, node B doesn't know the routing path. When C receives the packet from B, it's instructed to send to node D. This continues until the packet is received by node E. With every node in the network just blindly passing around information, it's nearly impossible to know the paths, origins, and destination of information. This is why Tor works as an anonymous network. But because Tor uses onion routing for anonymity, it's often assumed that the Lightning Network transactions will be anonymous as well. But this isn't the case. Tor node connections aren't limited to channels, and they also don't have publicly broadcast capacities and states, which Lightning does. So it doesn't matter if nodes B through D are blind to the path when anyone can watch the funds slide from A to B, then B to C, C to D, and finally D to E. Anyone viewing the network can watch every forwarding transaction taking place, with the transaction viewable, connections being permissioned, and given that every wallet requires 2 different nodes that always have to be online sharing information, transaction monitoring will most likely be easier on the Lightning Network compared to on-chain transactions. But the primary issue is that onion routing isn't dynamic. The path is encrypted by the first node. Every node along the path only knows the node directly ahead of it. If anything happens to the path during routing, their intermediary nodes don't have the knowledge to make adjustments. If paths to node D are compromised, C can't find an alternative path to E. If someone else's transaction shifts funds along your path, a node goes offline, or a channel closes, your transaction will fail. The Lightning Network is an extremely complex maze of abacuses that is in a constant state of change, and if your path changes or you come to a dead end, you have to start all over with a new, equally complex maze. Onion routing isn't path discovery. Onion routing isn't anonymous. Onion routing keeps nodes from being blacklisted. It makes routing more difficult after path discovery, which is the main problem to begin with. How does your node here know the path to here? Through millions of nodes while remaining completely decentralized. Every time you make a transaction, your node has to find all of the available paths to the destination. Make sure all the channels have a high enough capacity in which the funds are all shifted to the correct sides. It also has to take into account the relay price each node along the way has set, then compare all of the available paths. Find which one has the fewest hops and the lowest price. Then the transaction is onion routed and sent through volunteer nodes with varying internet speeds and processing power until the payment finally reaches the merchant with a near 100% success rate. This all has to be processed and executed before the constantly changing network has shifted your chosen path. On a network of nodes consisting of Raspberry Pis, cell phones, and old laptops. No one knows how this can be done at any meaningful scale, not without centralization. And you might be thinking, the Lightning is already on mainnet and this is just FUD. But this problem has not been fixed. No one knows how to do it. So that is the topic of the next video. The current state of Lightning Network routing, how far it can currently scale, and what you can expect in the near future.